Yeah, welcome to the YouTube Electricity and Magnetism username. Thank you for subscribing to this YouTube. Thank you for commenting. What I have for you today is this question that said, drive an equation to show that equivalent capacitance of a capacitor C1, C2, and C3 placed in series is this. Drive an equation to show that the equivalent capacitance of a capacitor C1, C2, and C3 placed in a series is this. Let's go ahead. That's why we are here. Solution. That's why we are here. Solution. First of all, let us look at the features, characteristics of what capacitor being placed in series. Look at it. If this capacitor is placed in series, this is the symbol for capacitor. They are put in series. Let's say this are put in series. This is positive, this is negative, this is positive, this is battery, which we call V, this is positive, this is positive, this is negative, negative. The charge, which is Q, flow this way. C1, C2, and C3. They are in series. What tells me that these people are in series? What tells me they are in series that the charge, this charge is the one that enter this man, enter this man, enter this man, and come back. The same charge flow through them. If the same charge flew through a circuit, flew through a device in a circuit, it means that they are in series. This is the same charge flow through this capacitor 1, enter capacitor 2, come out from capacitor 3. Then what does it mean? It means that the same charge which this man consumed, just like in occasion, they bring out a cooler of rice. That means the cooler of rice is given to the people to what? Share and eat. Meaning that that cooler of rice are in series to all of them. Everybody entitled to what? Eat from that cooler of rice. That cooler of rice is the what? The charge, which is what? Served to everybody. They are the same. Then, again, let us look at this. We say it again. The same these circuits, if I have this, let us look at the voltage across them. Let us look the voltage across them. I want to take the voltage across them. Look at the diagram. There's a Q. This man here, V1, is the voltage across capacitor 1. This V2 is the voltage across capacitor 2. This capacitor 1. And V3 is the voltage across capacitor 3. Here we say that current, the charge is the same, means charge is equal to charge 1 and is equal to charge 2 and is equal to charge 3. Meaning that the same charge that goes inside this man, goes inside this man, goes inside this man. Then in this occasion, what do you eat? Rice. They ask this person, what do you eat in that occasion? Rice. What do you eat? Rice. What do you eat? Rice. That means the same rice. Then here, in eating of that rice, the size of each of the people that is served that rice, the size of their belly, the size of their stomach are not the same. So somebody may consume 2 plates, another person may consume 3, another person may consume half. So that's their consumption is what we call voltage drop. The voltage drop across this C1 is the quantity of rice he consumed from that cooler of rice. This voltage drop across C2, this V2, is the quantity of rice he consumed from that cooler of rice, which may not be the same with this person because they are not the same stomach. They don't have the same equal size of stomach. This person doesn't have equal size of stomach with this person. Therefore, the voltage drop across this person and this person are not the same. We say that V, which is supply voltage, are not the same. Which means for me to get this, it becomes V1 plus what? V2 plus what? V3 will give me this man. Means they are not what? The same. For me to get the cooler of rice back, I will ask this person, how many plates do you eat from that cooler of rice? He say 1 plate. How many plates do you eat? 1.5. How many plates do you eat? 3. If I add the number of plates they eat, that give me the rice, the cooler of rice which is served to them. That means that voltage across this man, voltage drop across this man, and voltage drop across this man in series, and voltage drop across this man in series are not the same. Therefore, for us to get back our cooler, we have cooler of rice, we have to add whatever they have consumed. He gives us back to the cooler of rice we supply. This V is voltage what? Supply. We call it voltage supply. The cooler of rice we supply. While these Q1, Q2, Q3, Q2, Q3 are equal to the what? The rice. This means you just come back from the question. What do you eat? Rice. What they serve you people there? Rice. Then how many potato plates do you eat? 2 plates. That's the voltage drop across you. Why? I ask another person, what do you eat in that equation? Rice. That means rice is common. That means in series, it's served to all. The same charge flow through all of them. But the consumption, which is the voltage, are not the same. In series connection, voltage are not the same. But the charge that flow is the same. I think I've explained it to you in a clear ramification using here cooler of rice served to you in the occasion to explain to you. Then let us look at this. Then before we go this, you remember that what is capacitor? Let us go into what is capacitor. We have seen this. What is capacitor? Is a device used to store electric charge. Capacitor, which we are dealing with now, is a device which is used to store electric charge. And the quantity of charge which that capacitor will store is Q, is equal to, is directly proportional to the voltage supply. The quantity of charge which your phone will store. Your phone has a battery. The battery of your phone is just like a capacitor which store what? Charge, which you will make use after you have removed the charger from the light. The battery will start feeding you. That's the work of what? The capacitor. He store charge. Then we are not saying the quantity of charge which this capacitor or your phone battery will what? Store is directly proportional to the voltage you plug into. If you plug into the low current, low voltage, he will give you a little charge. If you plug it in a higher voltage, he gives you higher what? Charge. That means the quantity of what charge which this capacitor will store is directly proportional to the voltage across the terminal of the capacitor. You remember that capacitor have 2 terminals, which will call positive and what? Negative what? Terminal of the back of the capacitor, which will call the plates. Look at the plates of the capacitor, which we call parallel capacitor. This is the plate 1, plate 2. This positive, this negative. You plug it in a what? A socket. You begin to what? Charge. Then now, we have seen that the charge which a capacitor is going to store is directly proportional to voltage. Then Q is equal to what? CV. What is C? C is constant. C is constant of proportionality. Constant of proportionality. Called what? Capacitance. Capacitance of a capacitor. Capacitance of a capacitor. And this capacitance of a capacitor is ability which that enable capacitor to what? Store a charge. The ability. If you make this man substitute of formula here, you have that C is equal to what? Q over what? V. Are you following what I'm talking about? That means this man is a constant, which is what? Capacitance of a what? A capacitor. The ability of a capacitor to store what? A charge. The ability of a capacitor to store what? A charge. The ability of a capacitor to store a charge is what we call capacitance of a capacitor. So let us look at this properly before we go into deriving this. I have Q equals to what? CV. Then Making the V subject of formula, I have V equals to what? Q all over what? C. That means dividing through by what? C. I make V subject of formula. Again, this implies that making C subject of formula, I have C equals to what? Q all over what? V. That means dividing through by what? V. I make C subject of formula from this formula. Now we have seen the equation of what? Capacitor. Let us go back to what they asked us. They said right now, we have known the characteristics and the features of a capacitor connect in series, which we say the same charge flow through them and the voltage drop across them are different. We have known what we mean by what? Capacitance of a capacitor. Then now let us prove what they said we should prove. They said we should what? Show that what? The capacitance of a capacitor, which is this, is equals to what? 1 over capacitor 1, capacitance 1, plus 1 over capacitance 2, plus 1 over capacitance 3. That's what they're asking us over here. Then now let us show that. Then let us claim here for clarification. I'm going to claim this place. So since we have gotten this, let us claim here and get ourselves clear here. Let's look at this. Immediately this question is asked to me. Look at the question. They said equivalent capacitance of a capacitor C1, C2, and C3 are placed in series. Immediately they mention placed in series. What will come into my mind? The features in series. What's the features in series? The charge flow is the same, but the voltage drop across each capacitance, each capacitor is what? Different. So I will use this. V equals to what? V1 plus what? V2 plus what? V3. Why is up to V3? Because there are 3 capacitors. If there are 2 capacitors, this one will go. I'm talking about 2 capacitors now. If there are 2 capacitors, but right now what they are asking is 3 capacitors. That's why you have it up to 3. If they are up to 4, they will have up to 4. They are the same. Can we move ahead? Then now, since they are in series, placed in series, their voltage are not the same. Then, but according to what I did now, but Q is equals to what? CV. Then it implies that V is equals to what? Q all over C, right? Are you getting me? It said Q is equals to what? CV. It implies that V, making V subject of formula by dividing through by what? C. I have this. Then substitute. I will take this man to place for this man. Since V is equals to Q over what? C. I'm going to use this man to replace this in what I have mentioned here. I'm going to have what? Q all over what? C equals to Q all over what? C1. Why am I labeling C1? That's the capacitance. Capacitance along this man, V1. Plus, I'm going to have Q all over what? C2 plus Q all over what? C3. Are you there? Now, look. Somebody will ask me, since I label this one 2, label this one 3, why can't I label this one 1 as well, 2 and 3? Why? Do you remember what to say here? In series, the charge are what? The same. So no need of me labeling it. The same charge that flow through this person, look at it, is the same charge that flow through this person, the same charge that flow through this person, but their capacitance, their ability to store charge are not the same, which is their belly. Ability to store charge is the belly, the size of the stomach, which that capacitor will what? Take if this food is served. So the capacitance, which is ability to store the charge, are not the same, but the charge which is served to them are the same, which is what? Rise. Then and I come here to look at it. I will say Q all over what? C. And the Q are the same. I will say Q out. I'm bringing it out. Q is here, Q is here, Q is here. I can bring it out. When I bring it out, I will have 1. You know that Q here is multiplied by 1. When the Q leaves, it will drop 1, which gives me C1 plus Q. Here, I will have again 1 all over what? C2. I will have again plus 1 all over what? C3. And I will close the bracket. If you multiply this through again, you will have this back. You know that this is divided by 1. Multiplying to it will multiply the numerator, which is this times 1 will give me back this. This times 1 will give me back this. This times 1 will give me back this. I'm repeating. These are common. Q1, Q are common, and bring it out. I will have 1, 1, 1. So that when I multiply it back, this times this will give me this. This times this will give me this. This times this will give me this. You remember? Okay. Then now, for clarification, how does do this? Cross multiplication. Cross multiplication. You remember? Okay, for clarification, let me put this way so that you can be able to understand. Q over 1. This Q over 1 is same thing as what? Q. Anything divided by 1 is what? That value. Therefore, 1 times the numerator, this times the Q times the numerator, 1 times the denominator. You give me back this. Then let us do cross multiplication. Cross multiplication. I will have that what? C times Q, which is this. 1 equals to what? Q times 1. Are you get what I'm saying? Or to make it easier, because if I say cross multiplication, some of you will be confused about this. To make it easier, I want to remove what? Q. I divide through by Q. Divide through by Q. Divide through by Q. Divide through by Q. If I divide through by Q, I have Q all over C divided by Q equals to Q into 1 over C1 plus 1 over C2 plus 1 over C3 divided by Q. What will happen? This will kill this. And this we have Q all over C divided by Q all over 1 equals to 1 all over C1 plus 1 all over C2 plus 1 all over C3. You remember? If I kill this man is free. They are free. Then now, what happened here? I'm dealing with this person now. This all over what C times 1 all over what Q. You remember? This division, it will invert. Multiplication will be applied. Equals to 1 all over C1 plus 1 all over C2 plus 1 all over C3. Then this will give me 1 all over C equals to, you remember, this will kill this, leaving me with what? 1 all over what? C equals to 1 all over C1 plus 1 all over C2 plus 1 all over C3. Then now, you look at this. This is what they say we should prove. Then I can now say proved. I've proved that they gave me. Then again, there's something I want us to learn here. What I want us to learn here is this. Can I clear here? Let us clear here to get a clarification. We have proved what they said. We have solved the question they asked us to do, but I want us to learn more. We have solved the question they said we should do, but I want us to learn more. If this man, that implies if this man and this man are connected in series. How many capacitor is there? Let us learn more. How many capacitor is there? 1 and what? 2. The capacitance of this, 2 of this capacitor is what? 1 over what? C equals to 1 over C1 plus 1 over C2. And this can be written as C, which I'm looking for, is equals to what? Product. We call it product over what? Sum. Product over sum. How? You cannot find the LCM. 1 over C. LCM of this is what? C1, C2. This divide this will give me what? This divide this will give me what? C2. C2 times 1 will give me C2 plus this divide this will give me what? This. It will kill itself here, leaving me with C1. C1 times this will give me what? C1. Then cross multiplication, I will have that C is equals to what? C1 C2 all over C2 plus C1. That means whenever a capacitor, two capacitors are connected in series, I can simply say what? Product over sum to calculate their capacitance. That means whenever two capacitors are connected in what? In series, I can simply say, if they are asked to calculate their equivalent capacitance, I can simply say product of the two of that capacitor over the sum of that two. Are you getting now? Product of these two of them and over what? Sum of them. Then again, let us see when they are 3 in number. I can say this capacitor and also this capacitor and also this capacitor is connected in what? In series. Is connected in series. I can have C1, have C2, have C3. And we have proved it here to have this. Then let us see how the simplest form we can use to calculate such. Can I clean it here? I can now say here that capacitance of this, capacitance, which is what? 1 over C equals to 1 over C1 plus 1 over C2 plus 1 over C3, which we'll prove here now. I can now say that C is equals to products of the 3 of them, product of 3 of them, product of 3 of them. Let me write it clear. Product of what? 3 of them. Watch what I'm doing. Product of 3 of them over. Now watch me. Over C2, C3 plus C1, C3 plus C1, C2. Someone will say, how this person got this? How this person got this? This is a hell of confusion. It's not a confusion. When you resolve this, this is where you are going to arrive. At the time you are resolving this, I've already arrived where you want to land. So instead of you resolving this, it's better you say, I want to get the capacitance. I will do this. Let's see. What happened here? Find the LCM of this. Find the LCM. Look at 1 over C equals to 1 over C1 plus 1 over C2 plus 1 over C3. LCM 1 over C. 1 LCM of this is what? C1, C2, and what? C3. That's LCM. Are we there? Then now, that's the LCM of this, which you call the lowest common multiple. Then we look at this. This man divide. It will destroy itself, leaving these two. These two multiply the 1. I will have 2C3. Come on, we're moving. Then now, again, I'll bring that down the plus. This man go in. It will destroy itself, leaving me with C1, C3. I'll have C1, C3. Then I drop my plus down. Then what? This man going in here, it will destroy itself, leaving me with what? C1, C2. I have C1, C2. Then cross multiplication, I will have that what? C times into C1, C2, C3 plus C1, C3 plus C1, C2. Then this times this will leave me with what? C1, C2, C3. Then making the C subject of formula, they will go and divide. They will go and what? Divide. I will have that what? C is equals to C1, C2, C3 all over C2, C3 plus C1, C3 plus C1, C2. This is what I did. So by the time you are doing this, someone have already arrived here waiting. Substitute the value and what? Calculate. So that's the reason why you have to know this. Put in your brain that what? capacitance, equivalent capacitance of a what? Capacitor. 3 capacitor connected in series is solved by this. Why the 2 capacitor connected in series is solved by this? Because we are going to meet it in a subsequent what? In a subsequent lesson we are going to deal with. So you have to put them in your brain. And we have proved it that this manages. We have proved it. So we have also know that capacitance of the capacitor is C and is equals to Q over what? V. Alright. And this is what I have for you today. Subscribe if you love the channel. If you love what we are doing in this channel, subscribe, comment, and what? Share to your friends. Then if you have any question or something to clear, you can go through my email or my contact to get me more. So I dare to serve you. Subscribe, share, comment. That's enable us to move ahead. Thank you for today.